Hi, my name's Devin Petersohn. I'm a machine learning engineer at Intel. Today I'm going to be giving a talk called Data Scientists Are More Valuable Than Hardware, the Design of Modin. Effectively, this is about our insights into what data scientists are interested in when it comes to machine learning and data science tooling. We will share a number of our insights, as I mentioned, and a number of our design decisions that were based on those insights. Um, excuse me, I'll be talking a bit about Modin itself and giving a brief introduction as well as talking about roadmap. So there's a little bit of everything in here for people who maybe are using Modin or people who have never heard of Modin. You should be able to take away something from this. So to begin, I'd like to talk a bit about the data science landscape, as I like to call it. We're in this really interesting time where data science tools are scaling, but they're getting more difficult to use for the average user or the average data scientist. So here I have on the left tools that are used on a single node, on a single machine, perhaps your laptop, and they're typically used with smaller data sets. And then I have a sample of some tools on the right that scale to very large data sets, and they're typically used in a cluster. The challenge here, though, is that there's a big disconnect, and that's what this rift is meant to kind of explain here, is that there's a big difference between tools that are efficient for small data and tools that are efficient in larger data. So on the smaller data side, we have tools that follow typical programming styles, and they're widely used and understood in production. The majority of college graduates typically know this. So this is actually how we're teaching data science. The challenge here, though, is that they don't scale. That's a big problem because more and more we're needing to support data science at scale. That's why all these tools on the right exist. On the right, we have tools that scale really well, but they're difficult to debug and they require some distributed computing knowledge. So you need to know about partitioning, you need to know about a lazy evaluation, when is execution actually being triggered. Often that's kind of hated because it's counterintuitive. It was effectively, though, a kind of a product of being designed by systems people for systems people. So when distributed systems people kind of think about systems, they really want to be able to control the systems. Data scientists, though, want to be able to control their data and don't really care too much about controlling their systems. So that was one of our key insights here. And what we end up with is tools that are usable but not scalable. But then we have on the right tools that are scalable but not usable. And this is usable from the perspective of your average data scientist who is a domain expert in their scientific field or their business field. And in these cases, they're not distributed computing experts. They find these tools very, very difficult to use. So what ends up happening in a lot of companies is that we get a lot of basically rewriting. So you get a new data source or a new spec or new requirements. You do all the prototyping on like a laptop or a heavy duty workstation, and that's done typically in pandas. And then that notebook is then handed off to some data engineer or maybe a data scientist who has experience with these distributed computing frameworks, and it's rewritten to do some testing, and then it eventually makes its way into a production job. This is the pipeline for many, many, many companies. There's also a feedback loop here where if something happens in production or they have a question they want to ask, it has to go all the way back to the data scientist who is working on a single node to kind of prototype out this question and then send it back through the loop. So there's a lot of rewriting here that's happening, and that takes a lot of human time actually. But you'll notice that one of the challenges here is that there's no overlap between distributed computing and data science. So I titled this slide, Scaling Data Science is not just about the machines. It's not just about scaling, computing. Data science is about, cleaning data, interpreting results. You're really trying to just extract value from your data. Excuse me. And there's really nothing about that that overlaps with distributed computing expertise. Extracting value from data shouldn't really require distributed computing expertise. Scaling data science should be about scaling data scientists. Data scientist is much more valuable than the machine. And there's no cloud for spinning up more data scientists. They're a fixed resource. So we really need to be optimizing for our data scientists' time. Compute is cheap. We can spin up more compute as much as we want, but we can't spin up more data scientists. So we really need to be focusing on optimizing for the data scientist's time. That's exactly the motivation for Modin, effectively. We say scaling the capabilities of the data scientist with Modin. Effectively, what we want to do is we want to let the data scientists focus on the things that they care about, which is extracting value from data. So Modin is completely open source. You can find it on GitHub. It started effectively as a drop-in replacement for pandas, and what we noticed is that there was a big gap in these data frame operations and what you can do locally versus what you can do kind of in a cluster environment. So as I mentioned before, there's this need that data scientists have to be controlling their data, and data frames, pandas in particular, really gives you that feeling that you're controlling your data, and by extension Modin does too, because Modin is just a drop-in replacement for pandas. So for those of you who are familiar with pandas and Modin, you'll notice here that our API coverage has been expanding dramatically. So we're up over 90% on the data frame. This is out of something like over 600 total APIs in pandas. So there's a lot to do. There's a lot to cover. Now, you should also know, if you're new to Modin, that this doesn't mean that it will not work. Modin will basically convert itself to pandas and then apply the function if it's not implemented or not covered in one of these that I marked here under API coverage. But so it will still work. You don't need to really worry about that. But for those of you who are Modin users, you may have noticed in the most recent release a large increase in the API coverage. So at this point, I'd like to talk a little bit about Modin's architecture and kind of how we designed it and what was going through our minds when we designed it. So at a high level, Modin has a layered architecture, and it's layered, with very specific goals in mind. So at a very, very high level, there's an API layer that is abstracted out, and that gets converted into some data frame algebra, which is work that I did at Berkeley with a number of other wonderful people, and that then gets passed on to execution, which most often means Ray. So the APIs that we cover right now, we started with pandas, as I mentioned. SQLite is something that we have some experimental work for. It's there to try. It's not really good for production use cases yet. It's really just an experiment to see, what all we can do. The Modin API is something that we're still designing, and that's something that we want to get right. Now, the interesting thing about this architecture is that we can try, hundreds of different APIs that will all share the same underlying execution, so you can switch between them without any copying. The Modin query compiler is basically the narrow waist. It's the interface that lets us basically convert, any number of APIs down into the same common execution. And there are a number of projects that are actually implementing this interface, not just Modin, but there's OmniSci DB. You may be familiar with it. This interface is here to basically enable anybody to write and as long as they conform to this interface, they'll be able to take advantage of all of the APIs. And Modin was made as a community project. It's not trying to solve the world. So, if you have a favorite distributed data frame, feel free to, raise an issue or come talk to us about implementing that underneath the query compiler. Beneath that is the Modin data frame layer. The Modin data frame layer is basically our data frame algebra. That basically, so we start with about 600 APIs and pandas, and that gets drilled down all the way to about 14 APIs at the Modin data frame layer. So there's a lot of duplication, but what we've done is basically drill down the API to some low-level algebra that we can really optimize. And beneath that is execution, and most commonly that means Ray. Most of our users are using Ray, and they're happy with it. So I also put this here, bring your own distributed data frame. As I mentioned before, if you maintain a data frame or you're interested in your favorite data frame also being able to expose the Pandas API as well as all the other APIs, raise an issue. Happy to talk about that. So I mentioned this machine learning lifecycle before, where we end up with this big feedback loop of writing and rewriting Pandas code into Spark code. That's really, really common. What we wanted to do with Modin is effectively stop that rewriting phase. You can prototype in Modin, you can test and run production in Modin, and all of these jobs are basically the same notebook, the same exact code can execute on a laptop and in a cluster. So at this point in the talk, I kind of want to talk a little bit about our insights into the minds of the data scientist, if you will, and what data scientists really care about and what they don't care about. I think it's just as important that we understand what they don't care about as we understand what they do care about. We can really inform our decisions on like the requirements that we place on them if we understand what they don't care about as well. So the first key insight here is that data scientists work with a lot of different tools. They do care about their tools. Data scientists love their tools. And so a lot of times I've put, three different types of systems here: data frame, database, SQL database, and a spreadsheet. If a data scientist wants to switch between these, often it requires copying. You must copy to go from a data frame to a database. It has to go through the disk. And if it's a lot of data, that's a lot of copying. And, that just adds more time that the data scientist has to wait to gain insights or to extract value. So, when we think about how can we really make things as convenient as possible for the data scientist, what we really want to do is expose all of these APIs in Modin. Now, the interesting insight here as well is that data scientists often know a little bit of SQL and a little bit of Pandas, and you can go on Stack Overflow and find a large set of questions that is basically posting a SQL query and saying, tell me how to do this in Pandas, or posting something in Pandas and saying, tell me how to do this in SQL. With Modin, as I mentioned before, you can use these together and with the same execution, and there's no need for any of the copying. So effectively, you can switch at runtime between Pandas and SQL. And actually, we're working on a Spreadsheet API, and we've got some early feedback that tells us that this is a really positive direction to be moving Modin in, because the majority of data science is actually done in spreadsheets, believe it or not. So the interactivity there is really important. It's something we've been focusing on with Modin. You can expect something to come around the end of the year and be ready for use by the end of the year. But really, this is something that we're excited about. There's no system in the world that offers this really wide breadth of pandas and SQL and spreadsheets, all with the same execution underlying it. And so we're really excited to be to be at the forefront of this. So the second main insight that we had regarding data scientists is that data scientists don't care where or how their code is running. But we're not really treating them like that's the case. We treat them as if they really care, that this is running on a certain cloud. It must run on AWS, or it must run on, Google Cloud, or, data scientists actually don't care. Remember, their goal is to extract value from data, but we're putting these requirements on them. So a data scientist today must think about, am I running local, or am I running distributed? How many cores do I have? How many nodes should I provision? How much is all of this going to cost? What's my budget? What libraries are available to me? What APIs can I use from those libraries? All of these things are questions that they have to ask before they can even start to ask questions of their data. And now, when designing Modin, we thought that this was completely backwards. Data scientists should be focused on asking questions of their data. They shouldn't be focused on provisioning resources, or, orchestration, or, even worrying about whether they're local or distributed. They shouldn't really be having to change their notebooks even between these two. And so we designed a solution that basically allows you to connect to a cluster at runtime with just some simple commands in Modin. So it only takes a couple lines of code. You basically, this is available now in the most recent Modin release, but you can import from this experimental cloud import cluster, and then you create a cluster for AWS, and you have to have an AWS credentials file. Please take a look at the documentation if you're interested. But the key here, the key syntax here that really makes this valuable is the simple with statement. So with example cluster, and then in that code block, you basically write what you want, and it will run on that array cluster. And so we showed this to some of the data scientists that we work with, and we asked them for feedback. And one of the things that the data scientists mentioned was that it would be really great if we could connect to multiple clusters. And so we added that functionality as well. And so what ended up happening was that data scientists often work in many different clusters at once. And they're switching between notebooks in order to do this. And what the data scientists actually wanted was an ability to, switch between different clusters, but within the same notebook. And here we've given them a very, very easy way to do that. And it's actually, really, really nice syntax, because you can just take a look and say, with test cluster, okay, this code block is running on my test cluster. With production cluster, okay, this is running on my production cluster. So you can really spot check where your code is running and know, without having to remember, okay, I was, this notebook was connected to this port, or something, something crazy, which a lot of data scientists actually have to keep in their heads during the day. So the goal is basically to remove all of these extra requirements from data scientists, to empower them, to make them more productive, because, the final insight here, this is the segue, data scientists are more valuable than the hardware that they use. And this is something that is basically at the core of what we're designing with Modin. And so if you remember to the beginning of my talk, where I talked a bit about the requirements and the semantics and the APIs, learning about distributed computing, and how that's not really anything that overlaps with data science. All of these add to the burden of the data scientists, but they do so in the interest of machine time, or of scalability. And the problem is that all of these extra requirements actually decrease the data scientist's productivity, because now all of a sudden they have to think about partitioning, or they have to think about, provisioning more resources. And so what ends up happening is that we're trading data scientist productivity in the interest of machine productivity, or machine time. and scalability. Now, this is a real problem from my perspective because the data scientist time is orders of magnitude more valuable than the machine's time. As I mentioned, data scientists are a limited resource. They're a fixed resource, and we really should value them as such. Machines are cheap. It's very easy to spin up more machines. Data scientists, not so much. And one of the fundamental things that we really realized is that these requirements are not required to get improved machine productivity, scalability, and faster performance. To get performance, we don't need the user to specify partitioning. The system can actually decide that. For example, so with Modin, we basically took away all of these extra requirements. It's the same notebook, runs on your laptop, runs in a cluster, and this is basically designed to increase data scientist productivity and improve the machine time as well. Effectively, machine productivity, scalability, performance. Modin is basically trying to focus on the data scientist productivity first, and basically prioritize data scientists first because their time is so much more valuable than machine time. So with that, I would like to thank you for your time. Thank you for listening to my talk. Modin started as a data frame. And we're really evolving it into a framework for data science. We noticed that there was this problem of tools that didn't really focus on the data scientist. They more focused on the problems that the data scientist has. That's really, really important. It definitely is. But we really think that the future is going to be about optimizing for the data scientist. We would love it if you would join us, try Modin, give us some feedback. We really want to make data scientist tools usable at scale. Modin is, just over 2 years old. It's been evolving quickly. We have, a growing number of contributors, a growing number of users. You see here over 5,000 stars. Really, I present these numbers because it really shows that we're solving a problem that wasn't really solved before, like not in the way that we're trying to solve it. And there are a lot of people who are really excited about what we're doing, and we'd love to, talk to you if you're one of them. It's completely open source. All of the work that we're doing at Intel is open source. You can find it there on GitHub. The planning is open source. Feel free to ask questions, come by. All of our discussions are done in the open source. Please come by. We'd love to talk to you. It's easy to install with pip. You can also install it from CondaForge. We have a developer mailing list. Feel free to join the mailing list and visit our documentation. It's used at a number of companies. We have a growing number of use cases that people are finding with Modin that weren't really solved by other systems. And so we'd love it if you tried it, if you gave us feedback. We're constantly trying to improve it. Feel free to email me. By the way, I'm also a grad student at UC Berkeley in the RISE lab. Please feel free to email me at any time if you want to collaborate or ask questions. And with that, I would like to thank you for your time.